All right, let's jump straight into this explainer because if you've been watching how we build software with AI lately, you know the casual, easygoing era of AI development? Yep, it's officially dead. We are moving way past just asking a chatbot to spit out a Python script. We're stepping into this wild new era where AI is actually managing massive, self-repairing digital ecosystems. The blueprint for how this is happening is absolutely fascinating. Basically, we are trading out what's known as vibe coding for true, hardcore agentic architecture.
We have to kick things off with this massive, almost controversial realization from AI architect Daniel Twum's book proposal. He flat out declares it. The era of prompt engineering is over. Relying just on natural language prompts is a total dead end. Back in, say, early 2024, developers got completely seduced by this idea that you could just talk to an AI and it would magically build your software. Well, Twum argues that this whole strategy of hoping the AI just kinda gets what you mean has hit a massive brick wall. If you want to build real, lasting software today, you have to stop asking the AI to try, and you have to start commanding it to comply.
So there's this incredibly sharp contrast right now in the dev world. On one side, you have vibe coding. This is what most people are doing. It's intuition-based, it's developers just trying to coax an AI along with vague prompts and guesses. And sure, it works for a weekend project, but at scale, it literally leads to hallucinations, absolute spaghetti code, and just total chaos. On the other side, we have Twum's antidote, agentic architecture. This throws intuition out the window and replaces it with strict governance and rigorous engineering rules, specifically IEEE 2948 standards. It's trading all that chaotic guessing for absolute order and strict compliance.
Now, to really understand why this shift is absolutely crucial, we have to talk about the main enemy here. It's a phenomenon called contextual entropy. This is the thing that is quietly killing your coding projects as you try to scale them up. See, as we give these AI models larger memories, we're talking context windows expanding up to 2 million tokens, they paradoxically start to lose the plot. The logic just drifts, the AI forgets its early instructions, it contradicts its own architecture, and it starts hallucinating new rules out of thin air. Honestly, contextual entropy is the silent killer of complex AI apps. It is the exact reason your app works flawlessly on day 1, but is a total dumpster fire by day 10.
So how do we actually defeat this? Well, Twum introduces something called a recursive seed app engine. Basically, this forces the AI to write its own governing laws before it is allowed to write a single line of actual code. Think of it kind of like a constitutional convention for your software. You don't just say, hey, build me a database. No, you force the AI to first draft a strict set of operating protocols completely grounded in those professional IEEE standards that explicitly forbid non-compliant code. You're essentially building a strict governor that constantly watches over the system, making sure that logic never ever drifts.
Enforcing that constitution, though, requires a totally new division of labor. You can't just prompt one model blindly anymore. Modern developers have to orchestrate specific models for specific roles. Twum calls this the 2026 AI Triad workflow. Check this out. You use Claude 4.6 strictly for logic, reasoning, and auditing. Claude acts like the brain, it reads the codebase and produces structured gap reports. Then you hand those strict reports to Gemini 3 Pro, which handles the vision and implementation. Finally, you use Mantis for the actual mechanical execution. It's literally an entire virtual engineering department, and they're all operating in perfect lockstep.
Let's look at how this plays out in practice. It all kicks off with a mandatory sequence they call the OODA boot. This is a strict governance protocol that has to run before the AI is allowed to generate any output whatsoever. When a new coding session starts, the AI wakes up basically with amnesia. It has no context, so it is structurally forced to read its governance files, its constitution, before it even says hello to you. It checks the project scope, it scans for active specification documents, and most importantly, it has to explicitly state the task and surface any assumptions out loud. Absolutely zero guessing is allowed here. And I want to be super clear, these operating protocols, they aren't just theoretical academic fluff. They are a gritty, hardcore battle manual earned from actual incidents and incredibly painful system failures. Twum actually maintains a file called the Agent Operating Notes. Every single rule in that file is a rule written in blood. They were all born from a real-world mistake, some moment where the AI did something wild that broke the whole system. A rule only gets added after an actual incident, and it has to include the exact fix that makes repeating that specific mistake structurally impossible moving forward.
To put that into perspective, just take a look at some of these past incidents. Picture a server crash looping 72,000 times, all because of a manual restart. An AI once hand restarted the live app without explicitly declaring it was a production environment. The app got confused, looked for dev tools that obviously weren't there, and crashed over 72,000 times, completely maxing out the server's CPU. So the new rule? Never hand restart a fleet app. You always use the strict deployment script, period. Or consider the silent deploy failure, where an AI piped an error message into a black hole, turning what should have been a 2-minute fix into a multi-hour guessing game. These are incredibly hard-won lessons.
By binding the AI to these core principles, we're basically biasing the machine toward extreme caution. We are forcing it to act like a seasoned senior engineer, not some overeager junior coder who's just guessing at solutions. The AI is explicitly told, do not assume anything. If a requirement is vague, stop and ask. It operates on minimum code, you aren't going to need it, or YAGNI. No speculative features for later. It makes surgical edits, touching only the exact lines needed to fix a bug. And crucially, it has to observe before scoping. If one web route throws an error, the AI isn't allowed to panic and declare a fleet-wide outage. It has to systematically check the evidence first.
Now, inevitably, the AI is going to have to hand some risky steps back to a human. But when it does, it has to do so as a sequenced, checkpointed runbook, never, ever as a dense paragraph of prose. Imagine a non-expert operator trying to run a complex server migration. The AI provides exactly one command per copy box, using full absolute paths so there's zero ambiguity. After every single step, it tells the human exactly what output they should expect to see on their screen. And it builds in this ironclad safety net. Back it up, validate it, and give the human a clear, explicit undo command before anything actually goes live.
And that level of strictness extends directly into their security and formatting constraints. It's designed to ensure absolutely zero exposed credentials and to eliminate those infuriating character encoding crashes in Windows PowerShell. The paranoia here is actually brilliant. For instance, the AI is strictly forbidden from using placeholders like "insert your secret here" in commands. Why? Because a user might just copy-paste it without thinking and permanently log their actual password into their bash history. And formatting? Pure 7-bit ASCII is required in PowerShell, because a simple UTF-8 smart quote or an M- can completely break older Windows parsers and cause these silent, cascading errors that are literally nightmare fuel to debug.
So what does this all mean when you put it together? What is truly mind-blowing is the result of strictly enforcing all these rules. 256. That's the successful deployment of 256 apps, which Twum refers to as a full byte. This isn't just a handful of weekend side projects we're talking about. This is a massive, interconnected digital ecosystem. By fusing strict IEEE engineering standards with that AI triad and these battle-tested rules, Twum created a framework where AI can autonomously build, manage, and actually self-repair an entire civilization of software.
And to prove this isn't just science fiction, TechBridge University College is doing it right now, today. They are already running 109 of these independent containerized applications using this exact agentic architecture. They've hit 100% Docker coverage across their entire network. Their CI/CD pipelines are fully automated through Bitbucket. And get this, their AI agents are constantly autonomously auditing the ecosystem. They read the active code, check it against those locked governance files we talked about, and autonomously generate gap reports and fixes to ensure absolute compliance across over 100 live applications.
So, as we wrap up this explainer, I really want to leave you with a critical question to think about for your own projects. Are you still just throwing prompts at an LLM and hoping for the best? Just crossing your fingers that contextual entropy doesn't silently destroy your codebase? Or are you ready to embrace agentic architecture, lay down the ironclad rules, and start engineering your own full byte? The blueprint is out there. It's time to stop vibing and start building.